Tutorial is for 4th grade, Module 5, Lesson 15. In this lesson, we're going to use area models to change fractions so they have the same denominator, and this will help us compare the fractions. In question A, I'm comparing 1/2 and 2/3. The numbers are shown to support the fact that 1/2 is less than 2/3, but let's look at how we would do that on the area models. I'm going to start by shading in both 1/2 and 2/3 on the fraction area model. Because it's hard to make an exact comparison by just looking at pictures, we're going to change these pictures so they have the same denominator. To do that, I would start with my 1/2 piece. I'm comparing that piece to a fraction that has a 3 as the denominator. Or another way to put that is I'm comparing that fraction to thirds. So what I'm going to do is I'm going to draw my thirds on top of the half. So if I look down here at the bottom, I have 2 lines drawn across the model to make thirds. I'm going to copy that onto my half. Now, in all, I've broken the whole into 6 pieces, and 3 of those pieces are shaded. This shows how we can turn 1/2 into 3/6. I'm going to do the same thing on the bottom model. If I look at the top, there's 1 line drawn through the area model. So I'm going to copy that line to split the area model into half. Again, I have 6 pieces in all, and 4 of the pieces are shaded. This is how we change 2/3 into 4/6. Now I can do that straight comparison. If I have 3/6 and I'm comparing that to 4/6, then the 3/6 would be smaller because it's less number of 6. And that proves how 1/2 is less than 2/3. Let's look at another example. This time we're comparing 4/5 to 3/4. Again, I'll start by shading in each fraction. This first area model is showing 4/5, and the bottom one is showing 3/4. Now we want to change those diagrams so they have the same denominator. If I look at the bottom area model, there are 1, 2, 3 lines drawn across the area model to make those fourths. I'm going to copy those 3 lines on the top area model. So now we've broken our area model into 20 pieces. There are 5 pieces in each row, and there's 4 rows. And we've shaded in 16 of those pieces. So we took the 4/5, copied the fourths on top of that model, and we ended up with 16 pieces shaded out of 20. Now let's change the bottom model. If I look at the first area model, there are 4 lines drawn through that to make the fifths. So I'll draw those same 4 lines down below. And now I have 20 pieces in all down below. And of those 20 pieces, there are 15 shaded in. There's 5 in each row. So for 3/4, we copied our fifths on top of the model. That gave us 15 pieces shaded out of the 20 pieces that made the whole. Now we just need to compare these two fractions. 16/20 compared to 15/20. Well, 16 is more than 15. That tells me that my first fraction, 4/5, is greater than 3/4. Once we've completed the examples using the area model, we can think through these comparisons by just using the numbers. The first one is comparing 3/5 to 5/6. If I had an area model, I would copy over the sixths on top of my 3/5, and that's what this problem is showing here. So 3 times 6 is 18, 5 times 6 is 30. That means I would end up with 18 pieces shaded out of the 30. And then in my 5/6 area model, I would copy over my fifths. And that's the denominator from the first fraction. 5 times 5 is 25. 6 times 5 is 30. So now I'm comparing two fractions that both have 30 as a denominator. I'm comparing 18/30ths to 25/30ths. 18 is less than 25, so 3/5 is less than 5/6. Going across, I'm comparing 2/6 to 3/8. I would start by drawing my eighths on top of the 2/6. That would give me 16/48. 2 times 8 is 16. 6 times 8 is 48. On my 3/8 fraction, I would copy over the 6 from the first fraction. 3 times 6 is 18. 8 times 6 is 48. So now I'm comparing 16/48 to 18/48. 16 is less than 18, so 2/6 is less than 3/8. Moving on to problem C, I'm comparing 7/5 to 10/8. I'm going to start with my 7/5, and I'm going to multiply it by 8 because that's the denominator of the other fraction. 7 times 8 is 56. 5 times 8 is 40. Now I'll take my 10/8 and I'll multiply that by 5/5 because that's the denominator of the first fraction. 10 times 5 is 50. 8 times 5 is 40. Now I'm comparing 56/40 to 50/40. 56 is greater than 50, so 7/5 is greater than 10/8. And we'll do one more. Here we're comparing 4/3 to 6/5. I'll take my 4/3 and I'm going to multiply both numbers by 5. 4 times 5 is 20. 3 times 5 is 15. Now I'll take my 6/5 and I'm going to multiply the numerator and the denominator by 3. 6 times 3 is 18. 5 times 3 is 15. Now I'm comparing 20/15 to 18/15. 20 is greater than 18, so 4/3 is greater than 6/5. Using those area models at the beginning of the lesson gives us an explanation of how we can change our denominators to make it easier to compare fractions.